All right, greetings everybody. Now, look, what we are going to be looking at now, basically, we are going to be looking at what we regard as the molar volume of gases, right? Now, let's start here. Now, it is important, firstly, to note that in many chemical reactions, the reactants are mostly your gases, or gases are also formed during that particular reaction, right? So, now what you need to also know is that now the amount of gas, so the amount of gas, what we can do with the amount of gas, basically, we can be in a position to determine the gases that can be formed by weights, right? So we are saying we can be in a position to weight in the amount of gas that is formed. In other words, what we can do basically, we can determine what is going to be the mass of that particular gas, or what else can we do? We can do it by basically collecting it in a what we call a gas string, and also determine the volume. So we can also do it by collecting it in a gas string, right? We have what we call a gas string in order for us to be in a position to measure it, right? Or rather to determine their or its volume, right? To determine the volume of it altogether. So basically, now that's what we need to know. So what you need to know is that it is probably, most easier to determine the volume and then convert it into the number of moles and the mass by using the Avogadro's findings, right? It is almost, easy for us to do that. So now we are going to be looking at now what do we regard as molar volume at a gas at your STP. So we are going to be looking at what we call now the molar volume. The molar volume at at your STP. And I know probably most of you are wondering, what does this STP stands for? So basically this STP stands for standard temperature and pressure. So standard temperature. So it's going to be standard. This is temperature and standard temperature, and this is what we regard as your pressure, right? So that's what we are basically going to be looking at now. Now, for example, let's take this. Now, let's say you are having, different gases that have the same volume. So, basically, if this is your beaker, so you have this, this as your molecules or your atoms, and then after that, you have your, let's say you have your molecules here, right? You have your molecules, you have your molecules, you have your molecules, right? And let's say I give you another sample. We say now in this one you have this one and this one and this one, right? So these are basically some of the things that you have. And now we say if you have all these, and we are saying now these are different gases and they have the same volume, right? So which means the space that they occupy, this particular space, the space that are occupying are the same, right? Which means the space, temperature, and pressure are the same. Now what will happen to these particular molecules? All these molecules are basically going to have or rather they are going to have the same number of moles, right? So they are going to have what we call now the same number of moles. Now, so basically now what we then regard as 1 mole. So 1 mole of any gas at STP has. So now we are saying 1 mole. So let's write this here. So we are saying now 1 mole of any gas at STP has, rather will have the volume of what, of 22.4 decimeter cube altogether. So now then I know probably this might not make sense now, but let's start here. What you need to know is now, firstly, the molar volume of a gas is firstly abbreviated like this. Let's make up some space. So what you need to know is that firstly, now your molar volume of your gas is symbolized firstly by Vm, and is the volume that is occupied by 1 mole of a gas, right? So we are saying now the molar volume, it is now is the volume. So basically we are saying it is the volume occupied. It is going to be the volume occupied by 1 mole of a gas, occupied by 1 mole of a gas, right? So basically that's that. And what you need to know is that now Vm, what you need to know is that Vm now, which is your molar volume of all gases, Vm of all gases basically at STP, it is going to be what? It is going to be 22,4 22,4 decimeter cube, right? That is going to be the volume of all that. And now, and what else now that you need to know is basically now we also have what we regard as now your standard pressure, right? At STP. You remember we discussed about STP. So what you need to know is that now at STP, which is the standard temperature and pressure, now what you are going to have is basically the temperature. It is going to be 273 kelvins, and the kelvins can also be represented at 0 degrees Celsius, as 0 degrees Celsius. And now the pressure, the standard pressure, right? Our standard pressure, it can be written as 101,3 kPa. And then the kPa basically represents the what? It represents the kilo pascals, right? So this is the kilo pascals. So that's what are some of the things that you need to remember. So basically, I know now you are wondering in terms of how do we then calculate all of these things that we have shared. Now, before we go there, now one thing that you need to know is that basically, remember we said now volume of all gases at STP is going to be 22 4 decimeter cube. So for example, now if you can just do this example. Now, what you need to know is that now, for your example, uh, if let's say you are given this, your gas, right? So what you need to know is that now, you are going to have probably now 1 mole. They say you have 1 mole, which is represented by the 28 grams. Now, what you need to know is that this at STP is still going to occupy the 22 4 decimeter cubed volume. And similarly, even if let's say you are having your H2, right? And they are saying now your H2, we are saying now 1 mole of your hydrogen, basically your hydrogen gas is represented by what? It is represented by 2 grams. The same mole, as long as it's still your 1 mole, it is going to occupy the 22,4 decimeter cubed of the volume. Similarly, even if you can have this, your NH3, and let's say we are given that 1 mole of it. 1 mole of it is given by 17 grams. What you need to know is that it is also still going to occupy the 22,4 decimeter cubed of volume altogether. So these are some of the things that you need to consider about that. Now let's see in terms of now, how do we then go about calculating this? Let's make up some space. Now we have this formula which we say this is N is equals to your V over your Vm, right? So basically what you need to know is that now this N represent your what? This is your number of moles, right? So this represent your number of moles, right? And is given by a mole unit. And this now is going to be the volume of gases of a substance. This is going to be your volume of gaseous substance. So this is going to be the volume of gaseous substance. And now what we need to know is that we know that every time that our volume it is measured at decimeter cubed, and this is now going to be your molar volume. This is going to be your molar volume, right? And now what your molar volume basically, now this is going to be at, STP. And this is going to be a standardized value, or it's a constant, and it is always going to be your 22,4 decimeter decimeter cube, right? So this is going to be the molar volume of it. So basically, these are some of the things that you need to consider about that. Now, then let me just try and give you one example on this while we are still here. Right. Now, what is it that we can do now from here? What is important is, firstly, we are going to say, now for us to answer this question, we are going to check in terms of what we are given. So we are given what is going to be what the gas volume, right? So this is going to be the gas volume that it occupies. So this is going to be your V. Now we are given that this is at STP. So which means if it's STP, you are going to know in terms of what is going to be your molar volume, right? So basically now what we are going to do is we are going to start here. We are going to say now the volume. We know that the volume of volume is always measured in your decimeter cube, right? So since this is given by 224 centimeter cube. Now if you want to convert this to decimeters, we are going to divide this by 1,000 first. So what you're going to have here, it is basically going up to what this is going to be basically this is going to be 0,224 what decimeter cubed. And now when we are here, then what you're going to do now, we're going to say your N is going to be V over your molar volume, right? Because we are looking for the number of moles. So then what is it? Now this is going to be 0, your 224, because this is the volume of that particular gas. And now at STP, you know that you have 22,4 as your molar volume, and which means now the number of moles that are going to be produced there, it is going to be 0,1 mole, or the number of moles that are going to be found there, it is going to be 0,1 moles out again. So basically that's how we deal with our molar volume.